Okay, we've got another example here working with radicals. Notice we've got multiple radicals in this equation. Now, they might have started out on the same side. If so, the same principles apply. Let's isolate one side. And when we say that, multiplication's okay, because if I squared this side, the radical still goes away. But if I had like 2 plus a radical and you square it, then you still have a radical. So, radical on both sides. Let's go ahead and square both sides and see what happens. Well, over here, don't forget to square this 2 out front. So we get 4 times x minus 2, right? The radical's gone. Now negative 1 out front squared would just go away. It'd be a 1. So we get x minus 1 over here. Well, now we've got a pretty simple little algebra equation. Let's clean things up. So 4x minus 8, I'll just distribute there, equals x minus 1. Let's combine like terms and solve this. So if I subtract my x over, I'll get 3x. If I add my 8 over, I'll get what? 7. So x equals 7/3. Excuse me. But we need to check, right? Let's see if that would actually work. So if I go plug it into my original equation, I get 2 times square root of 7/3 minus 2 equals negative square root of 7/3 minus 1. Well, let's see if that's going to work. So 7/3 minus 2. 2 is 6/3, so that would be 2 times the square root of 1/3, right? 7/3 minus 6/3 equals negative, let's see, 7/3 minus 1, so that'd be 3/3, so that'd be 4/3. 2 times the square root of 1/3 equals negative square root of 4/3. Well, there's no way that that's possible, right? This is a positive number equals a negative number, and so, hey, there wasn't a solution to that one. That's why we always need to make sure we go and check those.